Alrighty, we are looking at the last page of the Topic 4 notes packet. And the last page of the packet is talking about asking a question at the top of the page. Can I prove these triangles are congruent? Okay, what we're trying to figure out is if we are given the information about the triangles that's in the left and in the middle of this table, okay, the congruent parts and the ones that match that picture, if we are given that information, is that enough to prove that the triangles in the picture are congruent? Okay, so there's a couple ways you can look at this. First, what I want to do is I want to clarify something. All of the S's on the left side of your page, that stands for side. All of the A's on the left side of your page, all of those A's stand for angle. So when you see SSS right here, that's talking about side, side, side. And that's saying if you have three congruent sides on the triangle, is that enough to prove that they are congruent? Earlier on in Topic 4, when we were proving that triangles were congruent, we had to have it where all three sides and all three angles were congruent. Okay, that is not necessarily the case, as we're going to talk about today. What we're going to do today is make our proofs easier by setting it up to where sometimes you only have to have three pieces of information to prove that your triangles are congruent. That's exactly what we have going on here. For side, 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 I'm going to color in, I'm going to trace over all three sides of both of those triangles because those are the parts that are congruent. Okay? In that picture, that is the information that is given to me. It says all three sides of those triangles, all the corresponding sides are congruent. And the answer to this question, is that enough to prove the triangles are congruent? The answer is yes, it is. It turns out when you have two triangles and all of the sides are congruent, there's only one way, there's only one configuration that the angles could take. So our definition of congruence, the way we talked about it before, was that all three sides are the same and all three angles are the same. Well, if you have all three sides, there's only one way that the angles are ever going to come out. So they're automatically going to fall into place being congruent also. So SSS, side, side, side congruence, that is enough. All right, up next, SAS. Okay, SAS, that stands for side, angle, side. What that's talking about is this right here. We've got two sides of our triangles that are congruent. Put those in one color and a different color. I'm going to mark the angles that are congruent. That right there and that one right there. All right, so in this case, we've got two sides. We've got two sides that are congruent, and it also tells us that the angle that is in between those sides is congruent to each other. Okay, so the answer, is that enough to prove that the triangles are congruent? The answer again is yes. All right, the answer again is yes. That is plenty of information. All right, I want you to think about this. These two angles that we have highlighted in red, those two angles, or those two sides, those two sides that are highlighted in red, those are hard set. They cannot change from one triangle to the next one. That angle that I colored in blue, that is also hard set, and it cannot change. So think about this. If you were trying to check if these triangles were congruent or not, if you stretched out side AB and tried to make it longer, that would change the angle C, right? That would make that angle wider. The only way that could work, unfortunately, that can't work because we already said that angle C, colored in blue, that is hard set. It's not going to change. So since angle C is hard set, that means the other side is hard set. That means everything in that whole triangle is hard set. It must be congruent from one triangle to the next one. Come on over now to AAA, angle, angle, angle. This is something that we actually talked about in the previous section of notes. There was a proof that we looked at that used this idea. AAA talked about angle, angle, angle. Okay, so when I'm using my highlighter, I'm coloring all three of these angles are the parts that are congruent from one triangle to the next. So the question, is that enough to prove that the triangles are congruent? And when you look at this picture, it's pretty obvious that the answer is no. Okay, you got to think about, what does congruent mean? Congruent means you have the same size and the same shape. Okay, so just because these two triangles have the same angles, they do have the same shape, but you can clearly see that the one on the left is way smaller than the one on the right. That is not the same size. There is no way those triangles are congruent. All right, so the answer is no. So what this means on your assignments, if you ever see two triangles with all the same angles, make sure on that assignment your answer is not AAA. Your answer needs to be NEI. That stands for not enough information. Not enough information. All right? So that's what your answer would be if it gave you a picture of two triangles with all the same angles and it said, what would you use to prove these are congruent? Well, you don't have enough information. You only have stuff about the angles and you don't have anything about the sides. That's not going to be enough. Up next, we are looking at ASA. That is angle, side, angle. So we've got two angles this time. And this time we're dealing with the side that touches both of those angles. The side of the triangle that touches both of those angles. Okay? You'll notice in this little diagram it says the side is between those two angles. That is a very good way to describe it, especially when it says that the label for this is ASA. You've got two angles and the side that is in between those angles. If you have all three of those things set, that absolutely is enough to prove that the angles are congruent. Okay, if you've got two triangles that have one congruent side and the angles that are attached to that side are congruent also, you have ASA congruence, and that is plenty enough to prove the triangles are congruent. All right, looking down at the next one, it is almost the same thing, right? This is another one where you've got one side and you've got two angles, but there's a difference here. Okay, the difference here is that this time the side is only touching one of the angles. The side is only touching one of the angles. Okay, so it matters. This is kind of like your corresponding shapes, kind of like your corresponding parts of polygons. The order that those letters are printed off, that matters. Okay, even though you have two angles and one side in both of these right here, you have to remember which one goes in between. And when I go around, like if I'm just tracing through this with my pencil, I'm looking at this and I follow around the loop. I run into an angle, and then a side. I run into an angle, and then a side. Well, if I'm running through my congruent markers on the previous one, I run through an angle, a side, and then an angle. An angle, a side, and then an angle. Okay, that's how you keep track of that. You have to remember which one is in between where. The order of that stuff matters. It makes a difference. In this case, both of them could be used to prove that your triangle is congruent. Okay? Both of them could be used to prove congruence. Let's come on down to this next one. This next one is another similar thing. Okay, up at the top of the page, we looked at SAS. This time we are looking at SSA. So again, we've got two sides and one angle. Again, we've got two sides and one angle, but this time there's a difference. Back up at the top of the page, when we looked at SAS, we had the two sides and the angle that was included in the middle of them. So when we traced our pencil around, it went in the order of side, angle, side. Okay? Just like that, when we're looking at this one, It's SSA. That means we've got side, side, angle. That's congruent. Okay? This one, unlike the last one, this one right here cannot be used for every single triangle. Okay, I want to draw y'all an example on here. Okay, you don't have to draw this on your own paper, but I do want to show you something here. Okay, let's say that we had two triangles like this. We've got two congruent sides. You know what? That's not very good. Let me try that again. I want to be absolutely sure I get this right because it's very important. All right. Let's say we've got a congruent side right there. We've got a congruent side right there. We've got a congruent angle right there. All right. That is the exact same setup that we have for SSA. We've got a side, and an angle that are congruent for both of them. A side, and an angle. I want to draw y'all another triangle right here. Okay? I want to draw y'all another triangle that looks a little bit different, but it's mostly the same. Let's say that we have a third triangle. It's got that same side right there. It's got the same angle right there. And we've got that. This side and this side are still the same. This angle is still the same. But when you look at these two triangles, they are not congruent to each other. You got to remember what congruent means. Congruent means the same. Okay? The same everything. Same size, same shape. All of the sides are the same length. All of the angles are the same rotation. Those two triangles, even though they have the same side lengths, they are not congruent to each other. Okay? That right there is how that works. You cannot necessarily say that SSA is going to work for every single one. And so for that reason, we're going to write no in that column right there. Okay, if you have an SSA situation, you cannot use that to prove congruence. And so if your diagram gives you two triangles with two sides and an angle congruent, but the angle's not the one in between, you again need to put, for your answer, you need to put that NEI because you do not have enough information to show if they're congruent or not. All right, this last one right here, HL. I want you to write down that this, so all the rest of those, they were S's and A's, sides and angles. HL stands for hypotenuse, and leg. Okay, the hypotenuse leg theorem, first of all, it only applies to right triangles. It only works for right triangles. And the other thing is this. Okay, well, I guess let's talk about what it is first, okay? The hypotenuse, this is a word you've heard before back when you, back in somewhere in middle school math. You learned what the hypotenuse of a right triangle was. That is the longest side, and it's the side that is not touching the right angle, okay? So the hypotenuse is this part right here that I'm highlighting in green. And what this is saying is if you have two right triangles and the hypotenuse are congruent and one of the legs of each triangle is congruent. If you have one of the legs and you have the hypotenuse, then you can say that the whole entire triangle is congruent. So that's an answer of yes. Okay? There's something else that I want you to notice here. Just because your problem has right angles in it, that does not necessarily mean your answer is automatically going to be HL. Okay? You have to have the hypotenuse or it doesn't work. There are a lot of times it'll give you a diagram. It'll give you a problem where you have two right triangles, like that and like that. And it'll give you that that side is congruent, and it'll give you that like this angle is congruent. Well, that doesn't say, those congruent markers don't say anything about the hypotenuse. Let me redraw this one. It'll give you something about like this, and that's a right angle, and it'll tell you that those two angles on the top are congruent. It'll tell you that those two sides are congruent, but it doesn't say anything about the hypotenuse. Okay? This right here is not going to be an HL. Okay? That right there is not going to do it. Just because you have right angles doesn't mean your answer is automatically hypotenuse leg. So what I'm saying here is this. If you're going to use hypotenuse leg, you absolutely must have congruent hypotenuses. You must have congruent markers on the hypotenuse. Okay, you have to make sure that the hypotenuse of each of those triangles is congruent, or you cannot use HL. All right, now that's all I've got for these notes today. Coming up after these notes, we've got topic 4, practice number 3, which there will be a video for also. We're going to finish those up, and after we work on those, we'll have the test review and then the test coming up. All right, it'll be good stuff.